Thoughts on what we need to do on example 2 now?
Distribute the x. Multiply both sides by x minus 4.
Okay.
What?
What's multiplying by x minus 4 going to do?
Cancel the x minus 4.
We want to cancel the x minus 4 on bottom. So we are going to multiply both sides of this equation by x minus 4 because that is our denominator. And it's our only denominator, isn't it? Okay. So let's work on writing this out. The first one, how do I want to write this out? When you have x minus 4 times x, for a moment I'm just going to write it as x times x minus 4. But what am I going to have to do? We're going to have to distribute, aren't we? Okay, and if I go ahead and distribute, x times x is x squared, x times minus 4, minus 4x, right? Okay, plus. Now, what happens when I multiply x minus 4 times 1 over x minus 4? Yeah, because if you think of that as a fraction, x minus 4 over 1 times 1 over x minus 4, x minus 4 in the denominator, x minus 4 in the numerator are going to cancel, and we are left with just a plus 1. Equals, what's 0 times x minus 4? 0. So, since I already distributed it, I have x squared minus 4x plus 1 equals 0. Thoughts on how to solve? What's your go-to method that you're trying right now in your heads? Factoring. No one's saying anything because you're running into issues? It does not factor, does it? Backup plan when it doesn't factor, said with such enthusiasm. Quadratic formula. Okay, guys. Quadratic formula, you gotta know how to use it. Negative b, which means 4 plus or minus the square root of b squared. So negative 4 squared minus 4 times a times c, which are both 1s in this case, all over 2a, so 2 times 1. Okay? Let's do some cleanup. 4 plus or minus, what do we have under that square root? 16 minus 4, which is 12, all over 2. So 4 plus or minus square root, 12, all over 2. Keep going with that.
Will it just be 2 plus minus square root of 6?
No.
You could do 4 times 3 in the square root, so then it would be 2 in the square root of 3.
Okay, yeah. So right here, first of all, you can't take square root of 12 and divide by a non-square root number. Okay, that's the common mistake here. But realizing we know that 12 is 4 times 3, and the important part about saying 4 times 3 is that 4 is a perfect square, right? So if we go a little farther with this, it's going to be 4 plus or minus. The square root of 4 is going to become a 2. Square root of 3 is going to stay a square root of 3, all over 2. Go one more step. Yeah. All 3 pieces have a factor of 2, don't they? Or take the 2 of the denominator and divide it into the numerator. 4 divided by 2 is 2, plus or minus. What about 2 square root of 3 divided by 2? Square root of 3. Okay?
Isn't it that all the numbers have to be divisible by the bottom number or you can't simplify?
Correct.
Okay. Good number.
Well, there could be a situation, I guess, where all the numbers are divisible by 2, and you can simplify that way, but you'd still have a fraction left. But yeah, they all have to be divisible by some. Okay. I said we're talking checks today, didn't I? Do we want to check this one the same way we checked the last one?
No.
Not really, do we? We don't really want to think an algebraic check here because I don't want to plug that stuff back in. I don't want to plug 2 plus square root of 3 back in. Okay, so we're going to talk this time about how you can check it graphically.
I like that.
Now, in order to check this graphically, these are our solutions we have, right? Where are these solutions going to be at on the graph? Where do you find solutions on the graph? On the x-axis, right? So what I'm going to suggest is you take the original function and set it equal to y. So we're going to take, I'm going to say, we're going to graph y equals x plus 1 over x minus 4. In other words, take your original equation equal to 0. We're going to graph that, and then we're going to check the x-intercepts. Or another name for x-intercepts are zeros. We have x plus 1 over x minus 4.
Yeah.
Okay. Random, but I see a slant asymptote there, it looks like. And a vertical asymptote. Okay, how can I check these? Okay, check the zeros. So if we check the zeros, second calc, second trace, 0. I can do a left bound, right bound, and I just got 0.2679492. Is that good or bad? How do we know? How can I figure that out? This 0.2679492 number, if it's good, it has to match up with either 2 plus square root of 3 or 2 minus square root of 3. So if I go and say, okay, what is 2 minus the square root of 3? Does that look familiar to what we just had? Yeah. Well, here, let me see what is 2 plus the square root of 3. Might be helpful to be familiar with these numbers, right? So 0.2, I'll just say 0.27 and 3.73 for right now. Okay. Can you go back and check your other 0 also? Yeah, you can go back and check your other 0. Remember, left bound, you're left of it. Right bound, you are past it. And then your guess, you're just around the area. 3.73, is it matching? It is. Now, I've got another option, okay? Hold on, let me mention one thing. 1e to the negative 12 as a y value. What are they trying to, what is that essentially?
0.
That is 0, yes. When they give you 10 to some negative power, okay, that's going to be 0. But here's another thought. You just go to trace, and you type in 2 plus the square root of 3. So if you just hit trace on the regular graph and type in 2 plus square root of 3, notice it pops up. It changed me to a decimal there, but where does it tell me that point is? At 0. If I hit trace again and type in 2 minus the square root of 3, it's going to tell me I'm right at the 0.2679 number. Okay? So, one way or another, work to make sure that they match. Okay? In this case, they both match, don't they? I'm not sure you'll have to use that check a lot in homework, but I wanted you to make sure you realize. Now, if we look at this, what is one answer we know could not have worked in this problem based on the original denominator? 4 couldn't have worked, right? Because 4 would have made my denominator 0. Keep those things in mind because those are going to be the more common issues you'll run into homework. Okay. Example 3. You ready? Example 3. 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. Okay. What kind of thoughts you have here?
Does the other side factor to be x minus 1, x minus 3?
Let's find out. Okay. Always look for factored form of these denominators. Okay. It's going to make life much easier. And there's a lot of coincidences that just happened. X squared minus 4x plus 3. What does that factor into? X and x. 1 times 3 is 3. How do we get them to multiply to be 3 and add to be negative 4? Both minuses. Coincidence? It's a very common coincidence, if so. Okay? So with that in mind, okay, the last 2 problems, we have multiplied by a common denominator, essentially. Okay? Basically, I've said, okay, what's the denominator? What's your denominator? And multiply by it. In this case, I had a denominator of x minus 1. I had a denominator of x minus 3. My other denominator is x minus 1 times x minus 3. So basically come up with what would be a common denominator. What denominator do you need that we can multiply everything by that will account for all the pieces? So what are my pieces here? X minus 1 and x minus 3. Okay? If I multiply by x minus 1 and x minus 3, that takes care of everything. So we're going to multiply both sides of our equation by x minus 1 and x minus 3.
We did something like this last year.
Yep. We certainly did. When you multiply by x minus 1, x minus 3, what is that as a fraction? You put them over 1 officially. Yeah, we've done this before. And in fact, I'm trying to remember, this might be my next Algebra 2 unit. I'm trying to remember what Unit 4 is. That might be what we start into next, or do we do radicals? I don't remember. But okay, so on the left, x minus 1 times x minus 3 times, okay, first fraction, the 2x over x minus 1. What happens in that case?
X minus 1.
Okay. X minus 1 and x minus 1 will cancel. What remains then?
X minus 3 and 2.
X minus 3 and 2x. So in the first spot, we're going to have 2x times x minus 3. I'll come back and multiply later. Plus. Now, second fraction. What happens? I have x minus 1, x minus 3. 1 over x minus 3. What happens? X minus 3 cancels. What remains? The x minus 1. Or if officially you want to say 1 times x minus 1, you could do that. On the right, what happens? Yeah. Okay, x minus 1 cancels with x minus 1. X minus 3 cancels with x minus 3. What remains? 2. There's some work that needs to be done, but is that a lot nicer answer or a lot nicer equation to work with? Yeah, let's do some math. We're going to distribute 2x squared minus 6x plus x minus 1 equals 2. What are you thinking?
Subtract 2.
What'd you say?
Subtract 2.
Subtract 2, make it equal to 0. And
Add the x's.
yeah, while you're at it, add like terms. Can we handle all that once? So 2x squared minus 6x plus x is going to be minus 5x. And if we subtract the 2 over, we're at minus 3. What are you thinking? Okay, product of AC. Flip and slide, if you prefer that.
No one prefers. Not.
Then how do I do it after that?
I wouldn't say no one prefers it, because I know I definitely have some that prefer it.
I don't remember how to do it either way.
Okay, I'm going to take product of AC, but I will mention
Okay.
the slip and slide here in a moment too, okay? So, product of AC. We need two numbers that multiply to be negative 6, because there's my A and C, and add to be negative 5. So what multiplies to be negative 6 and adds to be negative 5?
Well, I guess negative 6 and 1.
Negative 6, positive 1?
Yes.
This is always the confusing one, isn't it? Because we want to say 2 and 3, or at least my brain wants to say 2 and 3, but it's not 2 and 3 here, is it? So, now with product of AC, we're going to split the minus 5x into minus 6x plus 1x. Or, do you want to do a plus 1x minus 6x? Doesn't matter to me. Okay, but we're going to use those two numbers and we're going to split.
Oh,
Want me to do it the other way?
no, I didn't leave number.
Huh?
I didn't leave number.
Well, I'm going to end up over here, so I don't have enough room either. Okay, the 2x squared out front carries down, the minus 3 carries down. We split the middle term. We now have 4 terms, so we're going to split it in.
2.
Going to split it in half. And factor the halves. What's GCF of the first half? 2x squared and 6x both divide by 2x, leaving me with x minus 3. GCF of the second half has to be something, so we're going to say plus 1 divided by 1 leaves me with x minus 3. Okay, coming over here to the next side to work. Parentheses match, which is a good thing, yes? So what are my two parentheses here? Okay. 2x plus 1, the GCF. The GCF's x minus 3, my matching parentheses. Take each factor and set each factor equal to 0. So 2x plus 1 equals 0. X minus 3 equals 0. Got some answers?
Negative 1.
Yep. So 2x equals negative 1, x equals negative 1/2, or x equals 3. And what do we do before we move on? We check it. There's an obvious check on this one. I know one of my answers does not work just by looking.
Because it's negative?
No.
Because it's positive?
Nope.
Because it's a fraction.
Nope.
Because it's a whole number?
Because you said so.
Because 3 minus 3 is 0.
Go back to your original problem.
So I was right.
Denominators can never equal 0. I know two numbers that absolutely cannot be answers to this problem. 3 cannot be an answer to this problem, and 1 cannot be an answer to this problem. What did I just come up with?
3.
3 is a no-go. without plugging it back in, without checking a graph, without doing anything, because it doesn't work in the denominator, it cannot work. Okay? Now, in this scenario, to be honest, usually the negative 1/2 works then. Okay? It's usually the denominator that makes it not work. Can you check the original graph? Make your equation equal to 0 and graph and find out? Can you plug it back in? You can. Okay? But here's the deal. You have to make sure you check your answer, because that's more likely than not going to happen on these. Negative 1/2 is good. Okay? Do we want the brief slip and slide reminder?
Yeah.
Okay. So,
Who came up with this living slide?
I don't know who came up with it, but it's in the notes that Mrs. Rogers teaches now.
Does Roger see what
Really?
it
Robert.
It's in notes that she uses. So, okay, real quick, slip and slide. Let's see if I can do this on the fly. We're going to slide the 2 over here. So then it's x squared minus 5x minus 6. And then we factor it. Notice this is the same product and sum we just did, right? It's still that product of negative 6, sum of negative 5. So it's still the two numbers we just came up with of minus 6 and plus 1. Okay? The catch is, what did we slide over there originally?
2.
We slid over this 2. So that 2 now that we slid in now has to divide out. Okay? If it simplifies, you simplify it. So x minus 6 over 2 is x minus 3. Officially, if we're going for factored form, the 2 then goes back out front and becomes 2x plus 1. Or in our case, if we're trying to solve it, you could solve from right there, couldn't you? So let's slip and slide if that makes you happier. I don't know. I know I have a few happy with it, so. Okay. Example 4.
Yes.
Okay. What are our thoughts here?
Multiply by.
Well, it's equal to 0.
X with X and X plus 2.
Nothing.
So my one question, okay, so x is good, x plus 2 is good. Does x squared plus 2x factor?
Yes.
What does this factor into?
X with X plus 2.
X squared plus 2x. It's not a product in sum factoring that you were maybe expecting, but there's a GCF of x. So if I factor that, that is x and x plus 2, and what just so happens to match up? It's matching up with the other denominators, right? So use all of your factors as what you multiply by. So what do we need to multiply by? What are all the pieces that cover all of our bases here? An x and x plus 2. Everything's covered then, isn't it? So I'm going to multiply the left by x and x plus 2, and I'm going to multiply the right by x and x plus 2. Okay. First fraction, what happens?
The X cancels and you're left with X plus 2 times X minus 3.
Okay. X top and bottom cancels, x plus 2 and x minus 3 is left. Plus, okay, repeat this with the next fraction. X and x plus 2, 3 over x plus 2. X plus 2 cancels, we're left with
3X.
3 times x, 3x. Plus, what happens in the next fraction?
Both of them cancel and you're left with plus 6.
X plus 2 cancels. I'm left with 6. Equals, what about the right side?
0.
0 times all of that mess is 0. Okay. What do I need to do with x plus 2 and x minus 3? FOIL distribute, so x squared minus 3x plus 2x minus 6. Then I still have a plus 3x plus 6 equals to 0. Clean it up. I've got x squared
Plus 2x.
Plus
Is that it?
Yep.
X squared plus 2x equals 0.
Whoa, whoa, whoa.
What a coincidence.
Okay. How do I solve?
X and then x plus 2.
Does it factor? We can't think product and sum here because there's no constant term, right? But is there a GCF?
Yeah.
There is a GCF. X squared and 2x both divide by an x. So if you factor the GCF of x out front, we're then left with x plus 2. We have two factors, x times x plus 2, set each factor equal to 0. So x equals 0. X plus 2 equals 0. Gives me solutions of what? X equals 0 and negative 2.
It can't be -2.
Okay? It can't be negative 2 because,
It can't be 0 either.
Oh, God.
okay, can't be negative 2 because that makes that one 0. Can't be 0 because that makes that denominator 0.
Doesn't work at all. No solution.
That was just.
Okay.
Look at all that.
You know, that was nothing.
So, circle with a slash through it represents the empty set. So if you ever see that, that's empty set or no solution. And we found that out though because we were smart cookies and we checked our work, right? Okay, guys. 4 through 28 evens. Got a few minutes of work time. Use it.
It's